Hey guys, Jeff here. Welcome back to the bathroom remodel nightmare. We've got an interesting day today because yesterday's video, or last week's video, depending when you're watching it, was me putting in the subfloor. Rebuilding structure, laminating joists, reframing, doing an interior subfloor, and then another top coat, so now I got 1.25 inches. We've uncovered so many problems here that it struck me. One of the most common questions I get is, when I run into a bad situation, what do I do first? What should my steps be? Okay, so let's just walk through this today. We'll talk about the steps, and then I'm gonna take the time to fix them all. And this is gonna be one of these videos where you really wanna just sit back, enjoy it. I'm gonna have fun today, okay? We're not teaching as much as we're just gonna throw a lot of experience at you, all right? Make sense? So what I've got here is, I got cowboy construction, because I'm in a trailer. So I got 1x3 framing. 1x3 framing, that's to attach a shower wall. Like, that should just tell you right there. That's, you know, enough said. There's problems here. I've got just free-floating plumbing. I've got electrical coming inside the framework, right? I've got a plumbing vent here that snapped off under the weight of somebody falling in the shower, it looks like. Because this wall is so far not level. There's no strength in this wall. When you drill a 2-inch hole in a 2.5-inch piece of wood that's only 3/4 inch thick, you're gonna have problems. When this wall broke, I think the pipe broke at the same time. And then that opened up all this massive amount of moisture coming in from outside when it rains a little bit, right? And then even just the venting, because this is the vent, as you're draining your shower, all that hot and moist air comes up through the vent, gets trapped in this cavity. It's just rotted out this sill plate. That's just nasty. Ay. I've got mold on the drywall. I've got structural issues. I've got a vent sitting in the middle of my bathroom now. I've got drywall sandwiched in between the walls instead of finished on the interior. The way they build this house is they wrap the entire exterior in this vinyl drywall to act as a moisture barrier, I think. And then they did the interior walls. It's very much like commercial construction. Commercial construction, of course, all of that is on the inside of a concrete building, so it doesn't have, you know, condensation, heat and cold issues meeting each other, and which is why it's degraded. I've got a hole that used to be a door. I've got to frame that in. And then I've got, of course, insulation issues, framing issues. So we're just gonna walk through all of this together, all right? First of all, when you're doing construction, framing is first. We have framing. We got that wall, we got this wall. I beefed it up now, okay? I added a couple of 2x3s in the last video, just to give it some meat so I have something to attach things to down the road as well. These offer strength and stability for when I get into this bathroom, we start remodeling that one. That series will be coming up soon, so make sure you hit the subscribe button. We got a floor now, and that's it. So I've got problems. So I got to start going through my problems. Okay, do I have any HVAC problems? No. That's the biggest mechanical, all right? So if you got an HVAC problem, you deal with that first. Always. Biggest pipe goes first. The next biggest pipe is my venting and my drain. My drain is established in the floor. We're going to show you how to complete that in another video, but today we got to deal with this. This vent needs to be fixed before I go any further. Because it's the next biggest issue, okay? Once I get the vent fixed, then I'm going to be able to frame an interior wall so that I can repair the framing and then attach the plumbing to the new wall, okay? And then we're going to frame this wall and frame this wall, so then all of our plumbing is then in behind framing. Then we're going to go take a look at the back wall, and I've got to add a little bit of framing, and I got to start insulating my exterior, because you have to have your insulation on before you can start closing things up, right? And then once all of those framing, electrical, plumbing, mechanical, insulation issues are done, then I can put on my interior wall that comes out to about here. We'll have a shower, we'll frame in the bench. Then we'll be ready to close this part of the room. My goodness, this project was not a quick, simple flip. Sometimes you open up the walls and the floors and you get a bathroom from hell. That's what I got, and I'm kind of glad I did, because now we get to learn how to fix all this stuff together. So first step for me is the vent. Let's just jump right into this, because that was a lot of talking. My goodness. All right. One of the other biggest challenges I have is I got 8 million staples. I was going to say 1,000, but that would be a lie. There's a lot more than that. What I want to do is, how do you connect an existing pipe that's broken off right at the plate? Right? That's a $1 million question, isn't it? And I'm thinking, well, we could cheat. We could do a little bit of this. We could just put it in place, a strap, maybe a little bit of foam. The air will get through. It'll still vent. I'm like, no, Jeff, that's just stupid. Let's show people how to do things right. So today what we're going to do, since we're building another frame, I have this window of mercy to about here, of area that I'm not going to see the ceiling, okay? So I am quite comfortable grabbing my Sawzall, shoving it up in here and cutting the plate out of the way, and sticking on a coupling fitting. Okay, so let's just do that. And if you're not familiar, this is a coupling fitting, okay? It's designed for the pipe to go on each end, joins in the middle. It's just short. It's for situations like this where you don't got a lot of wiggle room. It's just... There we are. This is not the most ideal blade in the world for what I'm doing here, but that'll work. Whenever you're dealing with wood, you gotta force it to break. A flat screwdriver can come in really handy because it's got a nice wedge. You can go on off the edges and you can force it to crack. Take it off in little chunks. There we are. Now we got two pieces of pipe. Yeah, that is not cut. That is perfectly severed. Now we don't really need this to be all that watertight, but it's just venting. Here we go. I'm gonna use my little solvent wrench. Hold the can nice and level. This one makes a mess, huh? That primer, my goodness. Get it all around here as best we can. Oh, that Matthew had a 10. So let's see, where's the wiggle room that we got here? That one doesn't have any wiggle room. That one doesn't have any wiggle room. Well, that's gonna be the most merciful thing we got going on here. Let's get this in here. Not used to working with CPVC. Well, I'm not sure if it's got enough flexibility for me to force this in. Oh, apparently not. Well, what did I break? Bloody hell. All right, we gotta cut this sucker and do this in sections here. Yep. Gonna be one of those days, isn't it? This is just showing my inexperience here. Here we go. That goes to that side. I am not used to working with the CPVC at all. And so this is what's going on here. It works a lot better if you do two joints with this plate. Okay, because then you've got a coupling and a coupling and you can wedge it in. Trying to bend it, it didn't work with this. Now I gotta go open up the floor from the other side and find out what that noise was. Oh, God bless us. But that can be done from the other side. So I'm not gonna worry about it right now. It's just on my list of things to do. The good news is we have a crawl space. So even if I did break something, I can go into the crawl space and fix it. This is how you fix a pipe. Put a coupling top and bottom, cut the pipe into sections, and then it just snaps together real easy. There we all learned something the hard way. Well, better me than you, I guess, eh? Okay, now let's get back to our framing. One of those days, my goodness. So, what we got here is just a bottom plate. I'm actually building a wall with a top and bottom plate in the other room. This I'm putting in first, making sure that all of the holes around here, that potential gaps for mice, are eliminated. And because the wall is 9'6", I'm making sure that I'm increasing the actual height of the finish wall so that I can help get rid of this bow. We're going to show you how to fix the bow in this wall in just a second. There we go. This represents the plate, okay? So I want to take a look here. If I'm going to be putting a wall in front of this one and I want to pull this straight, this stud here is, and this is my biggest culprit, but in that corner as well. So what I want to do is I want to have a stud on the ends, obviously. The ones in the middle, I don't want to go over top of this because all these staples, I can avoid taking them out. What I'm going to do is I'm going to go just to the side of all those staples, and just to the side of this one as well. That creates a nice cavity for me in the middle for my plumbing, okay? So I'll take this, I'll draw these same lines on my other plate. I'll put 2 screws in each end on each stud. And then I'm gonna put in the notch 12 inches up, right? Let me just put that in at 2. Okay. Now I got my design, let's go execute. So basically what I did is I took my 33.5s, and this is the one that I marked on the wall, okay? And here's how I'm marking it. Let me just make sure this is clear to you. You're gonna see this when you put the wall up. You wanna see the X's, you wanna see a top and a bottom, T and B, right side. That's how you do this. Because if you get one of these switched around, your wall's gonna be all bent and crooked and weird looking. And organization is key. You set it on the ground in front of you, because this is how you're looking at your wall when you install. You take your top plate, pick it up, and walk it over. Set it where the top plate goes. All right, and then we're gonna take all of our studs here and check out and see if they're straight or not. This one definitely isn't. That can go on the inside because screws will always fix that. I'm looking for the best piece of lumber for my outside corner. It's gonna be this one, oddly enough. All right, and then these two, nothing's gonna be perfect. Don't look for perfect. You make the wall perfect. You don't find perfect lumber. Now this is a 2x3 wall because I'm still trying to maintain some space here. I don't want to lose an extra inch for nothing. Okay, 1 screw for every 2 inches of dimensional lumber or part thereof. So a 2x3 gets 2 screws because it's 2.5 inches thick. All right. Okay, go to the other end, we do exactly the same thing. All right, now we're gonna go back in the room, set the wall, but first we gotta do a notch. Remember, we measured looking at the wall from the bottom 12 inches up. We need a notch. Here we are, that's our notch. So we're gonna go 1 inch above and 1 inch below, but we're taking it off the back side. So, this is why having the writing on the face of this is so important. Now we're gonna flip this over and notch this lumber right here. NMD 90 wire, generally speaking, if you give it a 1/2 inch, you're fine. We're gonna adjust this for about a 1 inch cut because we have the ability to add a screw top and bottom with this. So we can be as liberal as we like. And when you have the option to be merciful, take it. Why don't you take that shot, or are you okay? The way you notch a board is you keep the plate flat while you cut, okay? All right. This is what we've done. Well, right through the marker. I have a notch that's the same depth on both sides. So I'm gonna take my claw and I'm just gonna hit the wood right here and pop it out. Now you see how the wood breaks on an angle because of the grain of the wood? So we might need a little bit more than that. But that's still lots more than 1/2 inch. I think we're gonna be good. All right, now let's go put this bad boy in place. So what we wanna do is get it in the room and lay it flat backwards so there's room to stand it up. On top of the plate. This is just gonna make it, eh? No worries, I'm upside down and backwards here. Okay. That's an important problem to have. All right. That's why we mark the top and the bottom, so we don't do dumb things like that. Okay. Well, if that isn't the perfect measurement, I don't know what is. Tight on the bottom, tight on the top, and look, I can stick my hand in behind there. Let's get the screw in this together. When you're working in a scenario like this outside corner is going to be straight across from the wall that I finished, and we're putting a door kit on. So this corner and this wall have to be extremely plumb. And that's level for all of us Canadians. So I'm gonna put my laser here, get it on that wood. Yeah, it's really out. I'm gonna start on the far side. I know that my wall here goes this way, so I'm not worried about my reference point quite yet. My first goal, attach it to the plate on the inside corner, nice and tight. Wire isn't pinched, everything is good. Okay, now I've got a reference point. I'm gonna attach it to this corner now, but just to the bottom plate. Okay, now it's not gonna fall over, and I can move it anywhere I want to. I'm gonna just kick this a little bit. Now I'm 1/8 of an inch off that corner, okay? And I like 1/8 of an inch, it's easier to read the level. In a perfect world, I would be able to go there. We're having an issue with level here. That's closer, but it seems like the bottom needs to kick out a little to the right. All right, so what I'm gonna do instead is I'm gonna attach right here, okay? And I wanna go that way. So what I do is I drive it in, back it out, and stay on reverse while I rotate around and get the right angle. And then I drive it in. Okay? What that does is it gives you really good grab on the screw. You can't ever do a screw on an angle like that right out of the gate. You gotta bore a hole, stay in reverse, kind of burning the wood in backwards, and then it gives you a pilot guide. So that's that one. We're gonna do the same thing over here. I got lots of wood, so I'm gonna do it here. Maybe we'll see it better this way. That's nice and secure. I am 3/4 to 1/8 of an inch. Wow. So both of the screws down here have to move. Now what I'm gonna do is I'm gonna slide my bottom until that red line is on this mark, which is the center of the wood. So that's where it is up top. And to confirm it, I'm gonna go right off the corner of the edge of the board. And I like that. Now I'll drive it in. Okay. Very important to note, this board has got a bit of a bow, okay? Good contact there, top and bottom. So what we want to do is drive a screw in here and push it over to the side a little bit. Push it up to the board, push it out a little bit, and let the screw pull it back in. We're dealing with 1x3s here again. Wow. And that is not gonna pull that wall tight that way. Our next goal is to get rid of this issue here. I'm gonna do that by driving in and on an angle, so I grab both pieces of that lumber. That's not grabbing wood worth of shit. Well, more wood here. Let's try this. Well, that's a little bit better. Frustration. It's a 3-inch screw. What do you say we just go straight in on this and try to pull this wood out? Well, it ain't gonna be perfect, sunshine, unless I tear this wall out and rebuild it. We're not getting into that. At some point in your renovation, You got to draw a line that says I'm not going to go any further than this, or there's no return on investment. At the end of the day, that gap, I can no longer get my hand in, right? So that's an improvement. It's just not going to be perfect. So this is going to be perfect. This is not going to be perfect. But what we are going to do is we're going to install 1/2-inch drywall here and with mud and tape. It'll give me the ability to make the appearance of perfect at least. Right? Appearance of perfect is good. The other thing I can also do is when I got my drywall here, I can fill in with mud, okay? And I've got a nice 2-foot trowel, maybe 30-inch. I can skim coat this wall to get rid of this bowl effect. And that's probably what I'll end up doing. So stick around for that. We're gonna teach you some new drywall tricks because we're not done with this wall yet. Remember, this is just mounted temporarily, right? Ooh, what a horrible sound. We wanna create a block system in behind this that mounts it permanently. And maybe that block that we hung is the block. But before I can finish this, I'm gonna get the plastic cap that goes on this because that sets the depth on it. Oddly enough, when they installed this, they left this behind, which turned out really beneficial for me. This, okay, is a depth setter gauge. What I mean by that is it attaches to the bracket, okay, and a little clip down here. And my finish wall can be anywhere from here to here. That's the finished thickness. So that's the face plus whatever tile or vinyl or whatever you're gonna use. Okay guys, so we're gonna just run through this real quick. Answer some questions that you're gonna have. A, why is the wall white? It's because it's covered in some mold. This wasn't connected properly. If you didn't see that video, check it out, links in the description. What a nasty installation. So we just sealed it up to encapsulate the mold, stop it from growing, keep it from getting in the air while we're working. Is we're gonna remove that bathroom and reinstall it. We'll remove this at that time, and then from that side, when all the wood frame is clean, we will then insulate between the two walls, okay? So I'm gonna close this without insulating for now, but that's all right. It's gonna get insulated. Same with here. We are gonna insulate this wall cavity. I am gonna wanna staple on my wall paneling for the bedroom first, but if we put insulation in here, then that'll help create a little separation from the bedroom to the bathroom. We're gonna do that for sound with the whole wall. And we will insulate over here for thermal, which is a different approach, but the same material. So that works out really well for us. Plan here is to build out a wall that encapsulates this pipe. So my measurement off the frame, I need to go 5.5 inches. That's a 2x6. So I'm going to have a 2x6 at this location, okay? And a frame top, middle, and bottom here. And I'm gonna build a 2x4 wall inside of that thickness plus the 2x4. 3.5, 4.5 gives me to 5 inches. So I'm gonna need to use a couple shims. I can either rip some 1/2-inch plywood or use shims where I make my screw locations. I'm thinking I'm gonna go shims just because the wall isn't level anyway. So the plywood is just gonna create the same scenario, still need shimming. So we'll just do that. We're gonna create a box here, a 2x6 here, incorporated with another wall that comes across at 40 inches here, okay? That's made of 2x4s. And that'll create a ledge right here. And the reason I want a ledge here is because then I got a shampoo bottle spot. It's kind of like a niche, only instead of building it into the wall, we're adding framing to create a ledge so that I can incorporate this into the shower. The thing about remodeling is I'm not allowed to move this vent. Okay? The minute I go to move this vent, it becomes a renovation. And I got to get a plumbing contractor in here and I got to get a permit in here. So designing around an element that if it doesn't move, keeps me inside my remodel, keeps me on budget. That's why I spin it around, because I got factory edge, bam, perfect every time. Okay, now, 95, eh? Here's a little trick with the saw. You probably can't see with this lighting, but this little black line here represents where my saw blade cuts, okay? Right there, next to this notch. Well, here's the 1-inch mark on my saw blade. So when I gotta cut an inch off of something, I simply set that on the edge of my material and cut it. One inch. Perfect every time. Done. All right, we gotta hop over the plumbing. Get past there, into the corner. Let's have a look and see what's going on here. Right off the corner. That is not bad. Okay. I think I got every wall moving in every possible direction here. Okay, so this is nice and level, which is good. But in order for this wall to be plumb, I have to go tight across here and open up a 1/2 inch gap in this back corner. That's incredible. So, because it's kind of an odd scenario, first thing I'm gonna do is throw a screw in it. Lock that joint down. Now that's nice and plumb. And then we got this one. Interesting, eh? Gotta get that line perfect too. Same thing. Gonna burn it. Now that this is perfect, this gap is of no consequence. I am gonna grab a couple of shims though. There's one thing I wanna do. So, I'm not sure if you noticed that, but I pinched that corner down there. This line was out, so I backed that screw off so I could move this into alignment. Now I got a gap. What I'm gonna do is get a nice thick shim in here. Okay. When you're using a shim, just hold it off a little bit. Gentle taps on the shim will get the job done. Because this is pinched, it's not really gonna move. Who would have thought there would have been that much room, eh? All right, now we'll drive her in. So now everything is plumb. We'll just throw a few more screws in it to secure all the corners. When you're building something, you can't just leave the wall as is. I got a gap here, I got tight here. I need a couple more on the base plate. I want a couple more on this 2x6. The secret here is we need to build so that with expansion and contraction, everything that is a different material in a different direction is tied together so that those joints aren't exposed to too much of the share of the load for the expansion contraction. Okay, that is really the secret here. Because I'm doing that as a sill plate, I'll come from underneath. Because if the screw is sticking out a little bit, it's not going to interfere with anything over here, right? Okay, I need a shim for that. I'll throw one in the plate here. And then I want to screw every 2 feet in this ball here. There we go. And then one up here. Okay, and we needed a shim here. Whenever you're screwing into a shim, hold it, okay? Or what'll happen is this. Oh, that wasn't as dramatic as I expected. Sometimes the shim will get whipped around with the screw, and it can cause you a lot of damage, all right? Okay, now I got a wall ready to build a bomb shelter. This is awesome. You know what I'm thinking? This is gonna feel just a little bit too claustrophobic. I am gonna add another 2x3 out here just to move the outside corner of my glass wall so I feel like I got lots of room. Yeah, don't wanna be claustrophobic. When you're building something custom, like the vanity, that can be whatever it ends up being. Make sure you got your good shoulder width apart. You want to have at least 32 inches on your shoulders. And right now I'm only at 30. So, having said that, and gonna listen to my own preaching, do I have room next to the toilet that I can build this out? That becomes the ultimate question, right? Okay, so the back of a toilet, if you're buying a new one, is generally 18 to 22 inches, okay? So, center of this hole, okay, half of that is anywhere from 9 to 11. That's the finish zone for the toilet. All right, so if I add 3 inches to my wall, okay, this is just the back of the toilet, by the way, okay? Don't forget the bowl is going to be way out here. And I put in a door kit. I got 2 options. I can do a slider. They usually require, or I can go with a 48. I can go with a 48 door. Okay, that's 2 panels. It's a fixed panel and then door panel. What that does is it gives me a fixed location around 24, and then the 24-inch door is the one that opens up like this. So you can see the old toilet comes out to around here. That's almost full open extension. That's not bad. So that's what we'll do. We'll add the 3 more inches, get our shoulder room. It's good to have this all figured out before you move forward, because I don't want to be building the wall here that's in the wrong location based on this corner without making sure the shower's wide enough. I'm gonna answer a phone. Now here's a great trick I'm gonna show you guys. So we're building a wall and we got a slope ceiling, okay? What I want to do is just draw a line here around my 16 mark, right? And I'm gonna go to what, 18 I said? Yeah, give or take. So we're gonna go like here, okay? That'll be the size of my frame. So what I want to do is take a measurement to that mark. We're going to call it 17 3/4. I'm going to mark it here as well. Okay? Really? Did I get that right? Oh yeah. That laser line there. Put a V on it if you're not sure. You start getting confused, mark your line with a V, okay? Make sense? So now I can line up this mark and this mark on the same laser line. Now, I know that doesn't make a lot of sense at this point, but that tells me, hey, my wall should go here when I attach it. Hey, my wall goes here when I attach it, and here when I attach it. And now I got a measurement for the top of my wall, okay? So, because my stud is gonna go to here, plus inside, and I wanna make a square here, right? Here's what we're gonna do. I could go all the way to 93 inches on this stud, minus the top and bottom plate. But then I'm getting into building angles and all that fancy schmancy, right? Keep it simple. We're gonna measure the small side of this box to this corner, 90 inches, all right? What I'm gonna do is I'm gonna make 2 at 87, and then our 17 3/4, right? 2 at 17 3/4. That's my top and bottom plate. That's my height. That takes me to there, coming across. I don't need to go to the ceiling. I'm not attaching to the ceiling, okay? The cement board will be. And it's gonna be just fine attaching to a framing that's 2 inches from the ceiling. So don't be worried about that. It's not necessary. Don't over-engineer your framing. Remember, everything inside of a 16 by 16 inch box is self-supporting. As a rule, when you get to the extremities like this, an inch or so from the ceiling, up to almost 6. If you're using cement board, is fine. If you're using drywall, 2. But that's why I like cement board, because it makes building easy. Now, boom, we have to build another box. But we haven't accounted for one more problem. This is 5.5 inches, okay, off of this framing. And this is 1.5 so far. And if I use 2x4, I get 3.5 out of it. 4, it gives me only 5. I'm still a 1/2 inch shy. All right, so then the question becomes, how level is this wall, all right? Because this one was okay. And if I'm just gonna go with what's going on with the wall, it makes it simple, but I wanna just double check. Is this wall as wonky as the rest of this place? To do that, I'm gonna throw a laser line off the corner of my horizontal cross pieces. That's really interesting. Fred, let's try it this way. There we go. Yeah, she's all over the place. When I came down here, I didn't bring my 6-foot DeWalt level, or I would just throw a great big level on this bad boy and find out. What we're gonna do is we're gonna build our box. We're gonna set it in front. We're going to measure out 5.5 inches from the bottom, okay? And then we are going to use a straight edge to put it, relatively speaking, to this corner so that we're flush off this corner in all the locations. At this point, level is not as important as flush. I know, what do you mean? You don't have to make it level. Not really, okay? So let's not get too worked up in it. I'm gonna make the box, let's set it in place with a straight edge. I'll show you what I'm talking about, because sometimes you can't make things level. You gotta be happy with flush, because at least flush allows a good installation, okay? And level only counts if there's a way to look at it and know. I'm gonna have a wall here. No one's gonna be able to see that inside corner until they're standing in the shower. And then be honest with me, when's the last time you got in a shower and went, man, we should get a laser level out here. Check, make sure that's perfect. Not gonna happen. Not gonna happen. We're gonna do the flush test now. Uh-huh. Uh-huh. Right? What I gotta do here is make sure that the bottom is connected, 2 points, and connected here. That is my flush mark. Bone again. All right, let's do this. All right, now, the thing about working like this is there's two things we're trying to do. One, we want connect the dots, all three. We're gonna assume that's level, or in line with this wall, and not out of square. To double check that, we simply slide this board across. Now we have 2 points of contact and 2 points of reference for measuring. I'm at exactly 2 inches, and I'm at exactly 1 5/8 inches, which means that this wall and this one are sitting open, okay? Does that make sense? They're like open like this. So now I'm gonna move this back in an attempt to create a 2 inch, or the same gap in this opening. I'm still at 2, I'm more than 2. Okay. Now, that's the money I want right there. Now, because I'm changing the plane, I'm gonna treat this like a fulcrum, something that this can rotate off of, okay? So, I have a perfect 2 inch gap here. So by setting this up at a perfect 2 inch gap, and throw a screw in it, which is temporary. Make sure that that didn't move in the process. Okay. Now these are parallel. That sets that corner when it's flush. Okay. Now that corner is in the perfect location. Holy f with the phone today. Okay. So let's get back to this. I have a parallel going on with my new plane as a fulcrum. So I line up where this wall is going to go, preferably tight to the corner. Just to pin that for a second, okay? And now I've got 2 new locations that I'm working with. So then this corner can move in and out as needed to close that gap. All right, now it's perfect. Alrighty, now I've got the wall set up. Okay, now, all I have to do now that the base is set up, is set this anywhere and move things accordingly, right? To make sure that everything is perfect. So, I'm gonna start up at the top. I got a nice solid line here. I'm going to secure this corner. That gives me 3 corners secured. And that'll pull it over. All right, and now all I got to do is secure this corner that's waving in the wind. I'm going to grab a couple of shims, one from each direction. So then every time I make an adjustment, it's sitting nice and tight. We're going to go like this with our wood. Okay, and that was a good guess. I'll throw a little bit more on there for good measure. Hold the shims so they don't spin. There we go. Solid as a rock. Now you can see, interestingly enough, this wall, I'm making contact here. I got a gap down at the bottom of 1/2 inch, and I got a little hair of a gap here, a big gap here. This wall is all warped. Okay, it's impossible to build like this. You can't just attach something straight to something warped, or it becomes warped too. Now try to do a nice finish on a warped wall. Good luck. Goal here, use establish your line as parallel, fulcrum, parallel, square, plumb. It takes a few minutes, but if you take time with the way you set up your building, when you go to finish everything, it snaps together, right? Everything just runs real smooth from here on in. And framing is, let's call it the most efficient way to maximize your productivity. Good framing makes everything else productive. Bad framing makes everything else take a whole lot of time. Note to self, if you're hiring people, make sure you check all the framework that's in the house before you let them close, okay? Because bad framing makes it hard on the drywall guys, makes it hard on the trim carpenters, makes it hard on the tilers, makes it hard on the floors. Everything is a disaster if you don't have good framing. So when you're hiring a contractor, if you're nuts enough to do it, I'm telling you, I think you should do everything yourself. But if you're gonna hire, you walk around with a square, walk around with a level, get a laser level, make sure everything is the way you want it, okay? Because no one's gonna fix it afterwards. All they're gonna do is work around all the mistakes. And all that work around costs time and money. They're gonna bring a bill at the end and say, hey, your framer sucked, boom, here's my overcharge. And that can all be avoided with good framing practice. All right, we're gonna get some shims in here now. Okay. Now that I'm shimming what I've already made, level and plumb, I don't want to over shim, okay? Because here's the practice. I've got a shim. It's thick and thin, right? And when you put the thin parts together and start sliding them together, here and here are both the same thickness, all right? And as I go, both ends are the same thickness as well as the middle. That's how this works. You can over shim to the point where you've made it really thick. And now you've caused your own bow in the wall. So when you're shimming and you have a space, shim until it's like gentle snug, give it a little bit more, just a hair, okay, like a quarter extra. Then you drive a screw, the screw will compress everything and it'll hold it nice and flat. That sucker needs a screw. Hold the shims from flopping around. And here comes the compression. There we go. Now I'm solid as a rock. I got screws on every corner. I got screws in the middle. This one is floating. It needs a screw as well. If I put a screw here on an angle, okay, I'm going to just catch the corner of that wood. I'll just get my marker out here and I'll give you an idea. So if I put a screw right here, okay, it's going to screw like this. Come on, marker. You're supposed to have ink on everything, okay? So now I'm going through wood, through the corner of the grain, through drywall, and there may not even be any framing or wood behind it. Let's double check. Maybe a bit. Inch, maybe a half. That's not the most exciting idea, is it? If you ever find yourself in that situation, do this, okay? Build out the frame like that. Yes, it takes a little bit of extra time, but it's scrap wood. You're gonna have lots of it laying around. Now when you screw, you can have confidence knowing you're gonna go into solid wood. Okay? Locked and loaded. Remember, each of these screws have an 80-pound shear strength. That's 160 pounds, making sure that nothing is gonna be moving around in here. Between that and all the other corners, you'd have to drive a car through this wall to knock it down. So now we've shown you guys how to frame some stuff. It's creative, right? But remember, it depends on the dimension of the material you're installing. Anything under 4 feet, you can be as creative as you want. Just try not to have gaps bigger than 18 inches. 16 is ideal. 18, you start to lose a little integrity depending on your building material. If you stick with your cement boards, or if you're gonna go a Schluter board more than 1/2 inch thick, then you can increase your gaps. This is framed, right? Ready to put some wallboard on, right? Nope, not done yet. What you want to do is you want to investigate. Take a look at your surface and think, I'm going to put cement board on here. What am I screwing it to? Uh-oh, right here. There's nothing to screw the cement board on here. So if I put cement board here, there's nothing back there. There's no backing. So what you got to do, now you got to cut some, what we're going to call back framing, all right? And this is a technique in the industry of just adding scrap lumber, usually in your corners, okay? with screws that will bond this wall to this wall at the corner joint so that your materials aren't moving around independently. Okay? We want to have about an inch, inch and a quarter exposed. Watch you don't have your hands behind that screw. It's a 3-inch screw. It's 3 inches of material. If you're holding onto it too tight and you drill too deep, you go right into your hand. I don't know how many times I've seen framers holding onto wood and using their framing nailer, fire right into their own bloody hand. Don't be a victim of your own stupidity. All right, that's back framing. I don't even have it here. This wall goes all the way in. This wall comes across. There's nothing to tie to back here. So, no problem. Let's go throw a little 2x3 in here. Okay. Bam. See how that works? Now, what have I got going on here that keeps that from moving? Oh, I got a shim. Okay. Here we go, guys. I know, I get excited when I see things coming together. We're going to go back framing here, right? See this? Same thing. This surface, we're good. Now this surface needed some framing. There we go. We're gonna go right off the corner. 2x3s. Don't give as much room to fool around, eh? Okay, so now that wall is good to the ceiling. I don't have anything here. And I don't have anything here. So I cut a 2x3 to go in my 2x4 wall because it doesn't have to go all the way to the back. It just has to be flush to the front. And it doesn't even have to be exactly the same size. So I cut it just a little skinny on purpose. Make my life simple. Remember, all we're providing is the backing. Let's give this something the material can be screwed to that's solid, that ties to the material next to it to avoid gaps and cracks. So we need to do again something here. Oh, it just hurt my hand. Hang on. Okay. Let's see. 4 feet will be perfect. It's a little less than I need, which is nice. Alrighty then. There we go. There we are. Okay. You see how this is all coming together now? I'm going to add 2 more 2x3s to the end to beef this out. Floor to ceiling. Good. Contact. This piece is now framed. This piece is now framed. This is good. This is all good. But when I go to here, I've got an issue. This corner here. Well, this is where we check our integrity at the door, isn't it? That's going to be a problem, Jeff. Man, if I was really paying attention, I would have insulated that first. But that's all right. We left it alone on purpose to show you some tricks. Okay, here we go. Time to insulate the corner, because we still have to add back framing to that corner, and we can't do that and then insulate after. All right, I don't care how many cans of spray foam you have, that's nuts. So when I just take my tape in here, it's looking like it's, what, 6 inches? Yeah, 6 inches of a cavity. I've only got a couple of options. I can't cut this stud out because everything on the outside is already attached to it. Makes sense? And the whole box is. It'll be a mess. Insulation is actually somewhat compressible. What we want to do is we want to like measure off the insulation, not the paper. Let's call it 6 inches, and then let's make it a little bigger. Because if you add an extra little bit to the insulation, let's say you cut it 7, all right, then we'll be okay. Now because it's paper face, it makes it easy. I cut right through the O and the U, right through the Johns Manville, right through the H. O and U. Right through the Johns Manville, right through the H. Okay? O and U. See how I'm saying that? Now, I'm gonna come along on a stud somewhere with my knife and cut through not just the paper, but the insulation. There we go. It might take you a couple of passes. And if you want, you can work with a bunch of really long pieces, or you can just cut them up little pieces at a time. Watch this. It compresses. So get it to the height that you want. And stick that sucker in there. Okay? And and then grab the back and then curl your fingers. Push that around the corner. Now, pull the paper to the front again and give it a tug. You want to make sure that it's not too compressed so that it has a chance to expand in the space. Now, we're just going to repeat that a couple of times till we get that cavity full. Okay. Whew, now we're insulated. We still need back framing, and I'll tell you why. This stud is independent of this stud. When I put two sheet goods together over that much of a span, okay, there's propensity for this wall to bow, all right? And up against this stud, if it's doing this in the hot, we're gonna have a serious problem. So I've gotta tie this sheet good to this wood. Here's how you do it. Okay, this is a 1x4. Yeah, granted, it's not a cheap 1x4. It's not strapping. It's actually designed to go around my closet. I'll just go buy another one because I wanted to get this filmed today so we all understand how to frame with integrity. There's a serious problem with that out there in the industry today. Not that people don't know how, that they don't walk in it. Okay, let's just try this out. This might be a little bit too wide for our good. I think what I need to do is I need to cut this down. Here's a better idea. Yeah, I forgot I had this. I have a piece of 4 foot by 4 foot 1/2 inch plywood. Generally, I like to have one on the job all the time because they make great shims, they cover holes, and in this case, they provide back framing. This goes in a lot easier, okay? And I can sneak it around, and because it's so thin, it's not creating as much compression on the insulation, help maintain its R value. We're gonna pull this out and hold it in place. Now you might be saying, Jeff, that's an awful lot of work to go through since the wood is so close. But shower systems especially need to have every corner tied tight together, okay? You gotta make sure nothing is gapping, because a gap in a shower system usually means a gap in the waterproofing as well. And if you get a gap in your waterproofing, no one cares how good of a builder it was, how nice the finish was. They want to know, why the heck wasn't it frame right? There we go. Backing. All right. Well, now that we got the perimeter walls framed, so we've got this wall frame, we've got this done, that done. We just want to finish a couple more details here. First of all, we want to adjust the plumbing because we're not ready to close until all the plumbing is in right position, obviously. And this is this is where it was originally. Now I'm standing on the subfloor, not even on the shower. The other shower had about a 2-inch rise on the floor. So can you imagine? You'd be like trying to shower. It's just stupid, right? We're going to get rid of the idea that everybody in the world is 4 feet tall, and we're going to raise this up because, God forbid, you're tall. You know the pain that goes with having a shower. We have tons of room, and we're going to be finishing the walls right to the ceiling. Now, we've got the water off at this point. I've drained the lines. I've turned off the hot water tank. It's gas. I've also turned off the gas. We can light that again later. It only takes a second. What I'm going to do is I'm going to switch this over and extend this much, much, much higher because we can add a coupling to a pipe. Not a problem. And so if I cut too close to this coupling, I have to cut it again on the top or the bottom. So let's just be smart about it. We'll cut close to where it's attached so there's less vibration, okay? And we're gonna cut away from us, okay? Keeping the pedal up against the material, nice and easy. There's always gonna be a little bit of water, don't get freaked out. It's called drops, they dry, all right? Now I've got this, I've got to ream it, and I'm gonna just use the end of my knife. Because the end of my knife is a V, it does a great job of reaming. All right, there's going to be crud from this experience going into this line, okay? So before we put the shower head on later on in the project, once we have everything done waterproof, we're gonna wanna have just the shower arm and turn on the water to flush the line out before you put your shower head on. That's all you gotta do, not a big deal, okay? We're also gonna clean this one up, give that one a bit of a ream. That way, any debris that's gonna be a result of what we're doing here comes off now and not 2 months after you've got it going and your shower starts to run a little slow because they have little aerators in them. And they can get plugged up with all the debris, okay? And then you're sitting here trying to have a shower under a dripping faucet. It just drives you crazy. Again, with the plumbing, we got a primer and we have an adhesive, the same as we did with the drain. for the purpose of doing this, we're just going to run this really quickly. I have to get an extension on this pipe. So I need the primer. Try to minimize the effect of this purple stuff. Okay. And we need the adhesive. This is a PVC cement. Works great in conjunction with the primer. And of course, if you're in Canada, guys, you're dealing with ABS. And it's a one solvent solution, but you have to put solvent on every piece, every fitting. Okay, don't cut corners and just use a little bit. This is going to be, whoop, that's not what I'm doing at all. I want to extend that. In order to do that, I need another length of pipe. Okay, let's cut that. Wow, I got carried away. All right, here we go. I want to have this up here somewhere. I like that. We'll go 14 as an extension. Can you believe that this was 14 inches too short? Crazy. 14 inches is about there. Again, this is not about being exact. This is about being merciful for tall people. Besides, if you end up putting in a rain shower head on something like this with an arm, it's nice if the water falls a little bit. It gets a little bit more pressure when it's falling with gravity. It does a better job of washing soap out of your hair. Okay, here's my other coupling. And we will finish this transition right here. Okay, and then the solvent. And we're going to stick it on, and then we're going to rotate it so that it's, boom, done. Plumbing made easy, right? Now, next thing we're going to do is we've got to mount something to secure this, okay? So I pre-cut a block that's going to fit up here for us. And there we go. I want to throw a couple of screws in it, but we also want to make sure we got the right depth. When we're talking about the depth, we don't want to have this sticking out past your finished surface. So, the secret here is to know what kind of room we have. Now I've got this vent pipe, so I got to be careful. I've got 3/4 of an inch, and this total size here is 1.5 inches. That's going to be close. I got 3/4 now. That gives me 3/4 again. That means that I'm going to put a 1/2 inch board on this wall, and then a 1/4 inch for my other adhesives and stuff. Yeah, that'll work just fine. Nice. Doesn't always work fine. Sometimes you got to change this out to a 1x4, or sometimes you got to pull it forward depending on the framing of the wall. If it's a 2x4 wall, you got lots of space. This is 2x3, so it's a little tricky. Whenever you're screwing this on, you got two options, right? I like to come from the outside and screwing in. All right. But I'm also right-handed, so sometimes it's easier to come from underneath. There we are. Okay, and yes, I'm using a combination of construction screws of the T25 bit. These are the 2-inch so that I'm using to install my flooring. All right, now, we want to have this somewhat centered in the shower, not concerning the shelf from where we're standing, okay? I don't want to have it shooting off my left ear. So, where I'm standing, I'm just going to go like this. This is the middle of my shower, right there, okay? So I really want to move that over. Just be aware what your center line is. This is also going to get moved to the center line because it's not ready to close until it's all ready to close. Now, let's just go like that. Here's our little gizmo. This sets up our depth for the wall, right? Remember that? Right now, the wall is going to come way too far out. I need to actually beef this up a little bit. Okay, so right now it is exactly flush with my framing, and I still have a little bit more room. Wow, that's flush with the framing. What I want to do is I want to bring that out at least 3/4. Let's aim for 1 inch, okay? The question is, do we have anything that's 1 inch? The answer is no, but we do have plywood. Okay, guys, here's a couple of rough cut pieces of 1/2 inch plywood. Now I am going to be screwing that together. Nope, I knew that was going to happen. That is nice and solid. Just for added security, grab your laser level. Throw a line on this bad boy, right up through the middle of this. And the reason this is so important, center line is a center line is a center line, and you cannot cheat. You want to put that in the middle of the faucet. I may not have all my tools on me on this job, but I'm always going to have a laser line. All right, now, part of the reason we want to do that is a lot of you are going to use tile. And when you go put tile in a shower, the grout lines scream where the line is. So if you're going to put your tile on center lines, you better have your plumbing on the center line, or it's going to show a rookie mistake. This wall is now ready to close, right? We've got our back framing, we've got our plumbing mounted, we've got all that done, and I'm going to keep this handy still, okay? Because even once I'm all finished, when I'm putting my wallboard on, I want to be able to see where that lines up on this, okay? Because that is going to be what gives me confidence moving forward. If there's going to be any problem, I can take the time to take this off, adjust my screws, throw shims, remount it if I have to, all right? Not a big deal. Now I went to Amazon because I went to Lowe's, I went to the Home Depot, I went to Ace Hardware, I went everywhere. They did not have this. Now if you've never seen this before, it's because the local hardware stores don't supply professional quality products for DIYers. This goes up here. It threads in. Did I show you that it has a gasket? Now this gasket right here, that's to keep the water from shooting out at you when you turn the water back on if there's an accident. Remember, not every shower valve is like this. Sometimes they can be inadvertently adjusted. You drop a tool, you hit the rail, it turns on. Doesn't take much. This makes the shower head waterproof so that while you're renovating, no matter what's going on with the position of the handle, you're not going to end up with water in your face or water coming through the ceiling while you're doing your plumbing and your floor. All kinds of options, right? Just a few bucks. I think it's like $7, peace of mind. And it helps when you're measuring because it gives you the outside diameter of the hole that you need for your wallboard and your tile and everything else. All right, so keep that in mind. So we're going to put a piece of wood here. We're just going to give a little tutorial because when you're framing, we have a rule about 16 inches on center. And that's what this is, right? Edge of one and the edge of the other. I mean, it's not perfect here, obviously, but it's pretty close. And that's because the cavity itself is 14.5 inches. Really? This one's smaller because of this piece of framing. But insulation, framing, sheathing, all these things, they're all working on a principle of 16 inch on center or something close to it. There's a couple variations, but insulation specifically is 16 or 22, or 24, sorry. And what they are is they already pre-made the insulation to fit left to right. You don't have to cut them or stuff them in a lot of cases unless they've adjusted the cavity depth like they did here. So to make my life easy, if I put the stick in the middle, both of these holes are going to be non-traditional, which means I got to cut both pieces to fit. So I'm going to take my 14.5 and I'm going to double check. Yep, it's going to go there. Okay, and that's on that side, and then my stud's going to go here, there. Okay, at least I only have to cut one piece. Do yourself a favor, you know. Okay, but before I can put the insulation on, I've got to deal with these 8 million staples, okay? You don't have to pull staples out, you just got to get rid of them from being, you know, propped out on the surface. All right, well, okay, let's talk about the insulation. I'm always amazed when you travel, the difference in building material. We have the same insulation thickness here, R13. It comes in almost 8-foot lengths, which is crazy awesome. So what you can do is you can start like this. You can measure the cavity, you can cut in advance. I like to do it the other way around. I like to do my insulation starting at the bottom. Right, shove that in the cavity, roll it up. Okay, because then I know exactly where I want to cut. Okay, because I got my stud right there. Here we are. Get your knife out. Cut it about a 1/4 inch longer than you need it. Okay. Then we're gonna stuff it into the cavity, all right? Here we go. And it's got these little paper wings on it. Take your staple hammer and then just tack it in place. Okay, if the staple doesn't go all the way in, turn around and use it like a hammer. Now we don't need 4,000 staples, okay? Just enough to hold it in place. So resist the temptation, oh, missed, there we are, to be crazy about this. I know it looks pretty if it's all nice and tight, right? This is not finished flooring. This is insulation. Get it in place, put a couple staples in it, it's not gonna go anywhere, and then you're ready to close. Now you'll see that because of this piece of framing right here, the hole is too small. And I can just squish it in. Most people would say that's done and good. I think that's just lazy. What I wanna do is stick it all the way up, eyeball my wood, cut it a 1/4 inch longer. Again. Okay. I also want to take the right measurement here and cut it about a 1/4 inch longer. What I'm actually doing is cutting about 1.5 inches off because it's one stud too many. Okay, so middle to the middle. And the same thing, push it all the way up to the top, set it into the hole, okay? Okay, so this is how you set it, guys. If it's tucked in nice and tight like this, if it looks pretty and organized, it's done right. If it looks like the guys that insulated the other side of the room when they built this place did it, they did it wrong, okay? You don't just jam it in and stuff it in. Whenever you see insulation like that, it should fail inspection. But we're in a temporary structure, so there probably wasn't any inspection. If you get my drift. Welcome to Quick Drain, folks. Here we go, lots of instructions. We will get to that in a minute. We got a drain cover. Here's the body assembly, all right? Now, without going into how it's assembled, we'll do that in the next video, okay? We'll actually build the whole shower. But what we wanna do is I wanna show you this. This is the drain, okay? So we're dealing with a waterproofing membrane system. This is a cap, we cut it away later, all right? But the basic foundation of the concept of this product is that it's a linear drain and it has this right here, okay? It's built in to drain at 90 degrees. Now there are foam block systems that go around this. So this will tie right into your CPVC and you can put this anywhere in the shower. And all you do is you cut this, throw a straight 90 on it and run the pipe right over and inside. Done. Nice and simple, right? So it doesn't matter where your drain is, you can get one of these. And then it also comes with an extension kit so you can make this longer, all right? And it'll funnel all the water to the middle of this drain and down and out. Okay, so what I have to do, have a quick look at this paperwork, installation guide. Okay, so based on the pictures, it can be a little shorter than the wall, but what I like to do is go wall to wall, all right? The concept of going wall to wall with a shower drain means that you only have one slope on each side. If you go shorter than the wall, then you have envelope cuts, which means you have to go angle cuts from here, angle cuts from here. You've got to redirect all your sloping and cut everything on an angle. It's a real pain in the butt. So by using this system, you can take any tub, rip it out of your house, throw this right on the subfloor. But first you have to open up your floor and then double layer your plywood like I did in the previous video, okay? In between your joists. This is actually a second layer flush. But then you can put this drain anywhere. Membrane, blah, 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 drain tracks, yes, 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 yes. Okay, we can put this anywhere. Good, got it, nice. So, what I have to do is, my limitation here is gonna be this. I'm gonna have a cement board, okay? So I'm gonna come out a 1/2 inch and I want my drain to come up to that point. And then I'm gonna have this as my wall and then cement board 1/2 inch, but that's my wall. Just physically setting it here, I can establish my wall. Boom. The secret with this whole system is having it on hand to establish the minimum. If you've got lots of room and you want to make it wider, that's great. But I am trying to be a little bit cautious Remember, my plan was to build a 2x4 wall to this point, put in a standard door kit. And the standard door kit for me is going to be 48 inch. Keeping that in mind, from here, minus a half an inch, 48 lands me about here. Okay? And that's good because what that does, this wall, let's just double check my total width. I'm still in planning phase here because I gotta get the exact details. I'm 6 foot 1 inch, okay? So basically coming off of here, 2 feet. And then that extra 1 inch that we're talking about is half inch laminated here, half an inch laminated there. That's good. The door kit can be adjusted up to 2 inches from 48 down to 46, so that's good. So we're gonna go with a 2 foot wall. And I know that I did that math real quick, but that's because I know all the products on the market and how they operate. So if you're not sure, go shopping and look at the door kit. If it says 48, it'll be for up to a 48 inch hole, but it'll also have a variance. Okay, so if you're going tile on tile or something like that, you can cut it down. Top and bottom tracks usually give you adjustments of up to an inch or two. The product itself will give that information, but just when you're going to build a wall, make sure that whatever you're going to put in that hole is off the shelf, and you'll save about $1,000. Otherwise, I got to call a custom glass guy. They'll wait until everything is done, come out, measure, make it, come and install it. And I'm going to spend about $3,000 to $4,000 on a custom glass door kit versus something that's $600 on the shelf that's already made for a 48 inch hole. I like the off-the-shelf solution. So we're going to build a 24 inch wall, but I have this depth to be concerned about. All right, so what I'm going to do is I'm going to measure that exactly from my 2x4 wall, 34 inches. Yeah, look at that. See this? That's the line I've fictitiously guessed. There's my new wall line. This is what this comes in handy because I can throw a laser on this point and on this point. Okay, see that? Line those two up. Bam. Now it shows me exactly where on my wall is going to go. So here's my laser line. I'm going to mark it on the stud. Okay. And on my paper, just for good measure. Because when you build a wall, you don't want to just attach the stud and the ceiling. You want something in the middle. So we're going to double check. There's no wiring here. There's my location for the wall. This automatically sets your wall level, by the way. Here we go. There's my other spot. Okay, and then even on here. Okay, so now I've got all my points marked. And here, there's my spot. So now I can build my wall, set everything on the interior of those black marks. I don't even have to level it. I just throw some screws and we're done. Now, because I've got this bulkhead up here made out of framing, this is solid wood, right? I'm going to actually build the wall, attach it to the framing, and then extend one piece all the way up to the ceiling as a cap. So I'm going to build this wall not 24, I'm going to build it 22 and a half, so then I can add another stick afterwards. That'll make it easy to cap it all up. Okay, I'm going to build my wall 82 by 22 and a half. Always write it down. Done. All right, we'll take that measurement, we'll throw a few sticks of lumber together, we'll build a wall, we'll stick it in, but first, I have to answer the phone. Now, because we wanted to save the ceiling box, just because, right? There's a lot of work involved in taking this down. This little piece of wood here, this is some of that particle board that they use for the subfloor. All right, I'm gonna cut this out. I'm gonna trim that up a little bit differently and get a piece of this clear glass, this acrylic, and throw it on the side. So when the lights are turned on, now I'm gonna have light shining through into the shower. Right? And I can put another piece of clear acrylic on this side as well after the fact, and that will give me a light in the shower without doing any electrical. That is brilliant. I know I'm impressing myself here, but that's fine. Now my wall is gonna go here, okay? And then afterwards, I'll take a piece of 1x3 and I'll reframe the end. It'll look very intentional. That's the plan. All right, just a good little cheat, being creative, but it's going to give me a light. It's going to mean I don't have to rip this out. Wow, if I put my wall here and I put my 1/2 inch cement board, I'm going to have to trim the surface of that in the shower as well. We'll use PVC and silicone. That'll solve my problem. And yeah, good for us. Go team. All right, let's build a wall. and get this screwed in place. So here we are, I'm dealing with a situation. I'm gonna bring you up to speed. That's the spot where my cameraman fell through the floor the other day. Love this subfloor. Just about got everybody here killed. This is where this was integrated, this new floor, but they stopped the bracing here. This here, yeah, this is garbage, okay? I can't build my new wall on top of garbage. I'm just not built like that. So what I'm gonna do is I'm gonna bring my saw and I'm gonna cut this section away so that I can put a piece of subfloor down that brace it and then cut in a piece of 5/8. I just can't put it on a piece of junk, okay? I'm gonna end up replacing all of this in the next video as far as the vanity video. But for right now, I've gotta deal with the integrity of this floor. I don't wanna build a wall on that. I mean, I'll probably get away with it, but I don't like getting away with things. You know, when you have an opportunity to fix something that's obviously wrong, you gotta take it. So let me just grab my saw. Okay. Yeah, that's so much easier. Okay, that's done. Of course, staples everywhere. We're doing all this again. All right. Give me a few minutes, guys. I'm just going to throw a piece of 2x3 here, a couple of screws so I've got a nailing surface. For the sake of making this quick, I'll probably throw one right here as well. Now listen, there's no harm in cutting your subfloor in sections as long as it goes from structure to structure and is less than 16 inches. So you can make your life simple like this. So I'm actually going 16 inches here. By 14 1/4. Let's just get this cut real quick. That is not a very good piece to do that with. Check this out. This is where it's laminated in the factory, okay? That's the thickness, but this is where the one piece ran out and they overlapped it. This section is thicker than it should be. I don't want to use that as my measuring tool. That's more consistent, okay? That represents the same materials I have over here. So, this is how I set this up. Take a screw on an angle. Just about 5 or 10 degrees is fine. Just to make it easier when I'm reaching in the hole. Okay. Let's get this flush. Probably underneath that corner is a good place to start. Right, but then, as long as this side is flush over here, it should all work out really nicely. All right. Now, this isn't really going to be carrying much weight, but I'm making a shower pan and a wall. My wall starts here. I don't want to have part of my shower where it doesn't transfer load right. Because, man, it would really suck if somebody did step that close to a wall and then it's separated, right, without structural underneath. It would really be disappointing. So, here, flush to here. Okay. Okay. Got the screws here, boys. All right, where's my piece of ply? Okay. One screw in each corner. So they're all 16 by 16. Okay. All we have to do is to get rid of the vinyl sheet here. That sets the thickness. It's in the way. Want to get down to the plywood. There we go. That'll be a lot more consistent. Okay. That's hilarious. Oh, there's an actual hole there. I'll turn it around. Are you kidding me? That's what you get for working quick. All right. We'll use the scrap. Alrighty, now I'm ready. Yeah, that's gonna work just fine. Okay. First thing is first though, we need blocking. Remember? We've got a screw surface down here for this. Right there. But nothing in the middle. And nothing up here. I really don't want to have to use this light box as my structural component. And when you're hitting these in, don't hit the block, hit half and half. Fluorescent tubes are always going to bounce around. Let's just kill that. And whenever you can, come from the other side. You're going to find 2 screws on one side and 1 from the other is enough. So all we're doing is putting 1 screw in to give it some stability so it doesn't move left and right. Okay? Here we go. If you're sitting there saying to yourself, man, that's a lot of work. Well, when you do it right, it's a lot of work. Because you want to make sure every detail and every aspect is built properly, right? You want it to last. No sense going through a labor of love like this for a 10-year shower. I got the bottom on my mark. Okay, now I'm just going to roll it up. I got here on my mark. I shove that back. I got there on my mark. I can confirm now with my laser. I can just run it right off the inside corner. And the back is a little bit out. So what I'm going to do is I'll start by screwing this down into the other plate. That pulls it back and holds it on the mark. And I'm using this laser line right here to make sure this is perfect. Right now, it's about an 1/8 out. You see that mark there? That's where we want to be. And you're going, Jeff, that's awful picky. Not really, because if I have this wall level and this wall level, I can measure the top, middle, and the bottom. And when I'm putting my wall panels on, okay, I can cut 8 or 9 of them all the same size. Right, and that makes things fast. Making things fast is money in the bank. We'll attach this. Now nobody can push against the wall and they're going to deviate. And now we're going to put it back here on this line. We need another mark, 34. Wow, that is absolutely spectacular. Okay, that's just in case I bump it when I'm getting up. I'm going to go into the plywood because I trust the plywood. Both ends. Now I can get my height to the ceiling. Remember, I don't have to have it perfect there. Now, I still have one tiny issue here, and that is I've got to screw that box to the plate. I don't have an option. I'm using this as a structural component here. Oh, time for a new battery. Oh my goodness. Here's a quick little trip. We're going to take this, we're going to push it up to the ceiling. Okay, and I'm going to mark the stud. Now, I'm going to take this measurement, 21 1/8, plus this measurement, which is 73. Put them together, 94 1/8. I'm going to leave it at 94 because I want a little mercy. Remember, the ceiling is not a structural element. So we're going to tap it 1, 2, 3, 4 there. This stud is actually not twisted this way. So that when I put them together, I create an L. And an L makes a much better outside corner because the wood, if it's trying to twist and warp, it's fighting against the other wood that's going in a different direction. Okay, so it keeps corners nice and square. And since I'm using screws, not nails, it's never coming apart. Okay. And this board has a warp to it. We'll turn it around the other way. I'm going to start at the top and lift it up off the ground. You see how this has a bow already? When I put the screws in, it's going to straighten out. It's going to get longer. There we go. There's one. That's going into my top plate. It takes 2 screws. Instead of screwing the bottom first, I'm simply going to put a... Oh, that's not going to work. Just going to tack it for a second. Okay, so I can set my screw. All right, so here's my top plate. 2 screws, okay? And then all the way to the bottom, I've got 1 screw just tacked in, and there's a little gap underneath, okay? But nice and flush here. Now watch what happens as we go up. We've got this huge bow on this one, okay? This one has a bow going away from it. So what we want to do here, right? That's normal. This is not a time to go back to the store and return your lumber and get a straighter piece of wood. This is your time to understand the power of a screw. So I'm going to throw it in. What I'm going to do is I'm going to pull them together using my shoulder. Done. Okay, now we've made a square corner. We're going to add a few more just for extra strength, but that's it, okay? This is why it bothers me at the hardware store when I see guys sorting through the wood. They're looking for perfect lumber, throw it in the back of their truck, and then by the time they get home and move it in and get it reassembled, it's all twisted and warped. Because there's no such thing as perfect lumber. It's all going to have a natural propensity to twist. It twists when it grows, and it twists when it dries out, all right? Stop looking for perfect wood. Because when you stand there in the pile throwing things around, you're causing the rest of the wood to get even worse. There's my solid corner. So when you're on a work site and you're in framing, you want to know, hey, is something straight? If you close one eye, look off the edge of a piece of wood, and then you can just go left and right, and it'll line up on another piece of, now there's something else straight in the room that should be straight. If they're both perfectly straight and you can check the next one, yes, 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 you can confirm all the framing in the room is straight just by doing that. Make sure it's plumb, sorry. And if you're going along like this and everything seems to be like in and out and in and out, it's either the problem with that wall or with this. So you can pull out your laser, double check both sides, but it's nice to have one stick in the middle of the room. You can just go around the room and eyeball everything, make sure it all looks right. Now's the perfect time before you close to make sure everything's square. Because once you get your closing material on, and then you start working, and you realize you're out of square, it's the wrong time to go fix problems, because now you're going backwards instead of forwards. Now, some of you are smart enough to realize that this mark does not line up with this outside wall. And you're right. What I'm going to do is I got to run to the store. That was the last of my lumber. I just got lucky. I need a piece of 2x4 and then a piece of 2x3, create an outside L, go down to this plate, frame up to the ceiling, and then I've got a nice wall here that lines up. The question is, what is my actual hole here? I'm at 50 inches right now, okay? What that means is, I'm gonna go confirm with my door. I'm also adding a 1/2 inch on each side. That takes me to 49, okay? So I'll get my door. I'm gonna buy that and get it here on site before I close. In case I need the extra inch, I can always add another piece of 2x3 on the end of this thing and load her up. You get the idea, right? Framing is all about plumb, level, square, problem solution, right? Keeping things organized, giving yourself options, knowing your plan, having products on site, making sure that everything's going to work. And here's a little bonus feature over here. This cavity, I have a vanity that I'm going to make myself. I'm going to set it low enough to put a vessel sink on it, because right here, this little vent, it's below the sink. That's below the floodplain. Unacceptable, any condition, temporary or not. That's just stupid. You're waiting for a water damage. When I reintegrate my plumbing, I'm going to bring that pipe over here into this cavity and bring it up here into this wall and leave section of this wall open so that it shares the air with the cabinet, which will have gaps around the doors, which will always pull fresh air, and it'll be above my floodplain. I'll never have a problem with my sink backing up.